Hi there, and thank you for joining us for this special on-demand webinar with TestForce and Tektronix, TekScopes for remote work. Before we get started, I just would quickly like to say that you're free and encouraged to share the webinar with anybody that you think might be interested. Simply share the email that you received or the link from our YouTube channel. I would now like to introduce our guest speaker, Rick Coleman. Rick has led products in software and hardware for over 15 years. Currently, he works as head of product at Initial State, an Internet of Things platform acquired by Tektronix in 2018. Before that, he ran product teams at multiple IoT hardware software companies and served as the director of product at Invidoo, an e-commerce video company. He gained deep knowledge in test and measurement software from his time at National Instruments, where he served as the LabVIEW product manager for cloud, FPGA, and embedded software. Thanks, Rick. Let's jump right into the topic.
Thanks, Rebecca. So today we're going to talk about a couple of aspects of remote work, and we're going to talk specifically about how you can do analysis off the scope and share files easily using TekDrive. So just kind of looking at a slide that you've likely seen many times and a concepts that you've likely seen many times. Everything is getting faster, more complicated, requiring more engineers to do the same thing, and getting and demanding less time to develop. And all of this is putting various pressures on the engineering, R&D, and test cycle. And some of the things and problems that are popping out of that, we're seeing that there's a requirement to utilize equipment efficiently, utilize people efficiently, do things both on site and remotely, and just generally make analysis and data ubiquitously available so that those things don't get in the way of this very difficult task ahead of you. So a big aspect of that from Tektronix perspective is we've taken the scope experience and distributed it such that you can install a scope experience onto your PC. And what this allows you to do is essentially everything a scope can do except the acquisition. And you might wonder, like, that's maybe not useful, but if you use a scope often, you know that making the acquisition, although it can be very difficult to set up and probe and trigger properly, you have a whole nother set of tasks after you've done that acquisition for analysis, measurements, and generally debugging the problem. So in the case where you don't have to have real-time access to a probing and acquisition system, you can take the file that you acquire and open it in TekScope on your PC from anywhere and have the full array of measurements and analysis. Also, TekScope, since it's the exact same UI as our mainstream scopes, it allows you to connect to scopes and control them. So in this case, you can connect to one or more oscilloscopes through TekScope remotely so that you can control the scope, control multiple scopes, and bring all the channels of those scopes onto the same screen for what we call multi-scope analysis. So let's take a look. I forgot to mention, of course, that the real thing that has obviously happened in this time frame is that COVID, right? And what this did is put a special pressure on remote work. It didn't necessarily let up on any of the other requirements that we talked about here in the beginning, but what it did is reduced further the access to assets like scopes and in-person ability. So what happened with TekScope over 2020 is that it just went on an exponential path because folks realized that being able to do work off the scope was a really important piece of their job, given the environment that we were in and still are. So let's take a look at TekScope. First of all, it's the full scope. So what it allows you to do is analysis. And we'd say it makes that analysis more productive because you can do it anywhere and on any machine. and it allows you to free up the scope for other folks to use, and you do your analysis where you like. It also supports Keysight and McCoy files as well as Tektronix files. And it allows you to remotely connect to mini scopes so that that analysis can be done in real time. Next, there's a big part of TekScope that is important for data sharing. I'm sure everyone has shared scope data with a screenshot, and that's not necessarily bad, but I imagine there's times where a screenshot was not sufficient to display or show what the problem was. And in this case, you can actually share scope data files like a TSS file or a waveform file with your colleagues. And because they have TekScope, they can open up that data in the full glory of that data. They can zoom and pan and do new measurements on that data. So there's a big part of data sharing that allows colleagues to work together on the same data set, but without doing things like making it into a screenshot, which just kills all the precision and understanding of that waveform in its raw form. Also, with things like TekDrive, which we'll talk about, you have the ability to share easily these TSS files across a cloud-based solution. TekDrive supports running a file from a scope or TekScope through the cloud to any other scope or TekScope system. The third thing that TekScope unlocks is this idea of multiple scopes. So especially in certain applications like power, where there are many different power rails that need to be analyzed all at the same time, you run into channel count issues in many different applications. Typical scope in our lines have 8 channels, and many applications require more than that. So TekScope allows you to take up to 4 scopes and up to 32 channels and trigger them all off of the same trigger, if you like, and bring all 32 of those channels into the same interface so that you and deskew those measurements so that then you can do measurements on the entire data set with TekScope, just as if you had a scope with 32 channels. And finally, TekScope allows you to augment an existing scope. TekScope supports waveforms from all different file types and all different scopes, so that even with a lower end scope or a less expensive lower bandwidth scope, you can do some of the measurement capabilities that perhaps are only reserved for a higher end scope by getting TekScope and plugging it into the acquisitions from a lower end scope. So that's something that's often used to take the capabilities of an existing scope and spread them further to something that is needed for the future. So I'm going to go ahead and we're going to just jump right in, and we're going to do some demos with TekScope and show various capabilities. We're going to go through 3 different videos of 3 different demos, and just go kick them off now.
We're going to do here is a quick walkthrough of the 5 golden demos. So the first golden demo is going to be on measurements. This can be found in your scope under Utility, Demo, Miscellaneous, and Measurements. What comes preloaded is one long acquisition with measurement 1 being peak to peak, measurement 2 being frequency, 3 being the period, 4 being the rise time. So we're going to show off the statistics enablement, maximum and minimum search, histograms, as well as gating. So I'm going to jump into TekScope here, which is the PC-based software. Going to go into Utility and Demo, like I said. In the Miscellaneous section, we are going to go to the Measurements demo. This is preloaded. I didn't set any of this up myself. It just came with TekScope. First, we're going to show statistics. So I'm going to double tap on measurement 2, and I have this button here to show the statistics in badge. Prime, this apostrophe here, indicates calculation is from the current acquisition only. So let's say that we were in run mode where we were acquiring a new record periodically, right? A full record, another full record, another full record. These measurements down here that don't have the prime would continue to grow in their sample size, and these top 2 would only be on the current acquisition. Because this is a saved waveform, it's not a live waveform, these measurements are all done on the current acquisition. So our average is 40 megahertz. This is a 40 megahertz clock, so it makes sense that our frequency would be 40 megahertz. Our standard deviation is 85 kilohertz. The maximum frequency was 40.27 megahertz, so only 0.27 megahertz above the average. And then the minimum was 39.73 megahertz, so just about 0.27 megahertz below. Sample size was 7,999 cycles during our 200 microsecond acquisition. So that's really quickly how you can look at statistics. What we can also do is we can add a results table in here for these measurements. And this is going to show us all of these in tabular form. So we have these on the current acquisition over here. These are the prime measurements, only what's currently in our acquisition waveform view. And then up at the top, we also have over the full amount of time since the memory has been cleared. So that's the first one. Maximum and minimum, let's look at next. So we have 7,999 as our sample. I'm going to single tap on the measurement badge. I'm going to hit minimum. We're now going to go and we're going to go look at what this minimum waveform looked like. So we already saw that it was 39.73 megahertz. Now we've single tapped on minimum and it takes us to that measurement. So we can see right here where we're zoomed at in our acquisition relative to the trigger point. And these orange vertical lines show us exactly where this measurement was taken. So the frequency was taken from this point right here on the falling edge of this clock cycle to this point right here, the falling edge on the next clock cycle. When I hit maximum, it's going to go take us to the 40.27 megahertz measurement, 40.269. And again, we can see where that measurement's taken on this falling edge and on this falling edge for one clock cycle. Really quick and really easy to then pan through multiple measurements, showing us the value of that exact measurement that's on our screen, and then we can toggle to the minimum, so the lowest frequency or the longest period, to the maximum. Next up, we're going to add in histogram. So I just double tap on this measurement, and I'm going to look at the histogram for that measurement. So a histogram sets up these bins, so as many measurements fall in the range of that bin are going to be shown. So the taller bars are those values that happen more frequently. So just one tap and we can look at exactly how this is laid out. Looks like some kind of a normal distribution. Double tapping on the background here, we can change the bin width, right? So if there are only 25 bins, they'll be much wider. We can go up to maximum, so everything is a very thin bin. And then if we're looking for outliers, we can go either linear or log on the y-axis. So right, 1 hit and 10 hits, it really enables us to see which bins are being hit more often. So that is histograms really quick. And then the last thing within measurements is gating. So I'm going to keep histogram plot up. I'm going to keep the measurement results up here up. Let's move this. Well, I kind of liked where it was at. Let's go down side by side. So I'm going to now double tap again on measurement 2, and there's one tab called gating. Let's go ahead and gate by screen. So all measurements set to global means that all 4 of these will be gated based on the selection I make here, or we could go to local and I could only have measurement 2 be impacted by the gating. But let's go global. We can gate by screen, so whatever is showing here in the waveform view, or cursors, so we can drag the cursors around. So I'm going to take these cursors, right? We see how the measurement histogram is updated as well as the sample size here. So we now have 1,042. As we move this around, we see that the table updates for us, the histogram updates for us, the statistics badge updates for us. Let's head over into gating and we could look at screen now. So let's hide these cursors. Let's change our zoom window so we have a wider zoom window. And as I drag this around again, we get to see how the histogram is updating and how everything up here in our plots is updating.
So let's take another show of TekScope here about how you zoom and search inside of signals.
going to go through golden demo number 2, which is zoom and search. We get there by tapping utility, demo, miscellaneous, and zoom. How to demo zoom, we're going to go ahead and change the horizontal zoom scale, which is shown right here, and we're going to drag this window throughout the signal. Then on search, we're going to demo how to search for a runt event. These are going to be the same user interface buttons as if we wanted to trigger on a runt event, but because we have a long saved acquisition, we're going to go ahead and search for wherever the runt events happened in our saved acquisition. I'm going to jump over to TekScope now, where I have done a default setup. So this is just as the TekScope software has been installed. I've done nothing custom to my setup. Utility demo. Let's find zoom, which is in miscellaneous. Let's go ahead and show this waveform zoom area. So we can zoom in horizontally, right? So I can pan myself here through the acquisition and look at exactly what's going on. I can zoom out to get some more cycles shown. Or we have the zoom box, right? In more, we can either select that we want the box to be helping us with visual trigger or with zoom. So I can click here and let's look, I don't know, let's look at this wide section right here, or we could zoom in at, just keep tapping it and we can hone in on exactly what it is that we're looking at. I'm gonna now, we can click the turn toggle zoom on or off button right here. It remembers where you were set up, and really quickly we can unzoom by tapping the zoom out horizontally and vertically. And then we can pan this through. So we have a whole bunch of data, so that's not as useful to us today, but here we can pan through exactly what's going on. So that shows the zoom. Now let's go ahead and look at search. Over here, search is a standard feature included on all 3 of these scopes. And we, for this demo, let's search for a runt. So a runt is when this is a good signal, this first one. So this is not going to be found by search, but this is where the signal passes a lower threshold and then passes an upper threshold and then falls back below the upper threshold and then falls back below the lower threshold. A runt trigger is defined as a signal that passes the lower threshold, enters the region, and then exits without ever passing that upper threshold. I'm going to drag the search box over to the side so we can see our scaling. So let's go ahead and set our lower threshold at 1 volt. And we can set our upper threshold at 2.5 volts. So we're going to be looking for any signal that passes 1 volt, does not pass 2.5 volts, and then drops back down below 1 volt. Double tap, simply type in 2.5 volts. I'm not using any separate units. And we're going to go 1 volt with no units. Very quickly, the scope went through this whole acquisition. 20 milliseconds at 2 milliseconds per div, 625 megasamples per second, and it almost instantly searched through that really long record. Just like in measurements, we can hit minimum and maximum, or we can cycle through these individually. It's a little bit difficult to see with the zoom settings that I had just set up, so let's single tap horizontal zoom until we get to a viewing setup that we like. And now as I search through these 7, look up here in the waveform video, waveform viewing area, we have pink triangles that show exactly where these runts are happening. Those are really helpful because they show me that it looks like it's periodic, right? We've got a 2 milliseconds per div showing right here, and it looks like it's 1.5, maybe closer to two divisions in between these. We could turn on cursors and drag the cursors to 2 of these, and this will really quickly show us that there is 3.27 milliseconds between these 2 search events, and then the frequency looks like it's about 305 hertz, right? So I can just pan this through really quick. I don't need to set up any complicated measurements to see that we're seeing about 306 cycles per second where we have this runt event happening.
So finally, let's take a look at how you can do digital decodes from an analog acquisition and decode the digital waves.
4th golden demo, we're going to go ahead and show off protocol decode. We're going to use the very easy I2C signal, kind of the standard signal that anybody and everybody can decode. I just want to show off just how easy it is to do on these 4, 5, and 6 series mixed signal oscilloscopes. nobody can do it as easy and reliable as these three scopes here. You're going to see just how easy it is to demo this, to do this setup, and to kind of mess around with the I2C decodes using TekScope. So we're going to pull in the standard demo you can screenshot. We're going to hear of how this is going to show up in your scope. We're going to delete away the results table, the bus decode, and this search. So we're going to kind of start from scratch. If the customer had just acquired channel 1 clock and channel 2 data, how do we get to a useful analysis setup? Let's jump into TekScope, where I have done a default setup. This is TekScope just as it is installed. Open up the serial bus tab, where we currently have 18 different serials in, we have demo files for all 18. You can see summary of that serial bus, as well as the procedures of how to do this demo live once you've got hardware and we're all back on the road. I've double-clicked on I2C, so you can see down here it's setting up our channel 1 clock, channel 2 data. We have the bus decode, results table, and a search. Let's delete out bus 1. So it's going to delete bus 1 and search 1, and now our table is empty. I'm going to get rid of the waveform zoom area. So this is just as if a customer sent you an acquisition, right? We're going to show how to decode based on a signal that's come in. So let's add a new bus. In this bus type list, we see everything that's available with the license that we were given from the TekScope team. We can go ahead and set these thresholds. We see over here on the right that maybe 2.5 volts is a good threshold for our clock. 2.5 volts is a good threshold for our data. So 2.5, I'm just typing on my keyboard. We could also, probably better during a demo to tap in 2.5. We're in volts, so we don't need any of these other scalars. Channel 1 is our clock. Channel 2 is our data. And look at that, it looks like our bus has started to populate. One question that comes up sometimes is what this red triangle means. The red triangle is showing us that there was no acknowledgement error. So this is something that we've built into this signal so that we can demonstrate that our decode packages can catch these errors, and just by tapping this, you can toggle through any of the errors. It's moving the waveform viewing area so that the zoom is only showing the important information for this acknowledgement error. All right, let's go ahead and zoom back out. So I now have the bus decoding properly. We have data coming in. We said that we're going to add a results table, single tap results table, and we want to add bus decode. So click on add. Let's set this up so that the bus decode results table is on the right half of our screen. So I simply just click and drag so we can position things wherever we want. We can, go through this table, single tap on any of these lines here. So based on start time, what the address was, what the data was, or if it was an error. I'm using my mouse wheel here to roll through the table. Oh, I'm interested in 12. Let's tap on 12, right? Or what's going on at 20 milliseconds. I'm going to click through these that are happening around 20 milliseconds. We can zoom in further. And as we click through these again, the zooming area follows whatever horizontal and vertical settings we've set up. Lastly, let's go ahead and add a search in. So we're going to search on the bus type. Let's search for an address. The addressing mode, these are in 10-bit right now. And let's go ahead and search for XX2. So we see 42 different events. Again, these arrows right here, just like in measurements, just like in the run search that we did in our previous video, single tap through these and it's going to toggle us all the way through all of these 42 events that were found. So we have 393 packets that were decoded, and 42 of them ended in a 2, right? So we have 152, 102, 152 again, 102 again. So it looks like we're seeing some 152s and some 102s. Double tap again. Let's go 152, and we see 21 events, and 102. We see 21 events. So really quick and really easy to start to see, oh, half of them are 152 addresses, and half of those are 102 addresses. Up here in the waveform zoom window, we see the pink triangles that are showing us exactly where those happen relative to our trigger point. Again, it looks like they're periodic, right? We see an even spacing in between these. Really, really quick and easy to demo the decode capabilities. And remember that inside of demo and serial bus, we have 18 different decode standards available to demo, right? So let's just open up CAN-FD really quick. Again, just like the I2C example that we did, you've got the waveform showing here. We've got the channel 1, digital, the bus decode, the table, and the search. Really easy to demo these capabilities.
So I hope you enjoyed those demonstrations that showed how you can use TekScope to really do deep analysis without having to be in front of the scope. All of those demonstrations were based on pre-acquired signals, and none of them required you to be at the scope. So let's talk a little bit about the acquisition and how to get data into TekScope so that you can utilize this remote work capability. So the ways that you can get data into TekScope are the following. First, like shown in all of those demonstrations, using data files. Data files like TekScope files, TSS, waveform files, like we mentioned, many third-party type files are supported, so you can bring in those. You can use transfer mechanisms like a USB stick or across a network. And also, we'll talk about this, but you can use a cloud-based transfer capability called TekDrive. We'll actually show how you do that in a second. Another way to get data from acquisition system, a scope, and into TekScope is through remote connections. Both USB and LAN connection are supported with TekScope on many different scopes. You can check the data sheet for the exact supported scopes for remote control. In those situations, you can connect over USB and LAN and refresh the waveforms in TekScope directly off of the scope. And in some cases, you can get real-time connection to those scopes directly into TekScope, and we'll take a look at that. And then finally, TekScope, as it is a full set of software of the scope, it actually supports PI commands. So as a pro user, you can actually get data into TekScope without using the GUI even. And you can even use TekScope as a disaggregated measurement system that runs on a PC, and you're able to farm out measurements to the TekScope package running on the PC instead of farming out those measurements to an actual scope. So I said we'd take a look at TekDrive. TekDrive is another Tektronix product that really enables remote work. And of course, it enables all the things that we also enjoy about how the cloud helps our everyday lives. TekDrive's goal is to make your test and measurement data just as accessible and shareable as your consumer life, where you're easily never lose photos or contacts. We want to bring that level of experience to test and measurement data. That's what the cloud can do, ubiquitous access and super shareability. So the first sort of feature of TekDrive, I should say, is the ability to have a file system in the cloud and share those files with anyone. It's much like Google or Dropbox, but Google Drive or Dropbox, but we'll talk about why this is a differentiated system versus just a typical off-the-shelf cloud file system. One of those differentiations is that you can actually mount a TekDrive on a scope. You can mount the TekDrive in TekScope, the software, and that gives you a one-button capability to save directly from the scope to your TekDrive account. Furthermore, inside of TekDrive, we have visualizations. So instead of being able to open a document or other things in some of the other systems, in TekDrive, you can actually open a TSS file or a waveform directly in a visualization and do some basic measurements. We'll take a look at that. Also, you can securely collaborate with your team, so you can share data with other folks securely, and you can have a folder that's shared with your entire team, and so everyone can put their stuff in the same folder, and then it's instantly shared across wherever. And then finally, TekDrive is completely driven by an API. So although there is browser capability, you can look in your in a typical browser and explore your files. You can also explore your files inside of TekScope or Scopes themselves. It's all API driven, so you can actually use TekDrive behind the scenes to store and aggregate data for some automations that you're building. So let's take a look at how TekDrive and TekScope work together. So here's TekDrive. You'll see that it's very much like a typical file system. You can explore folders and files. I'm just going to jump into this one called Scope Sessions, and I'll pick out just a file called FFT 3 channels, and I'll just share it with someone. So this is an example of how you can just simply share this with your colleague. You can share this in a view or edit capability, so there's permissions that you can add. And then still in the browser, I'm going to take a look at that file, the actual waveforms inside of that TSS file. So this system is actually breaking apart that TSS file, pulling the waveforms out of it, and placing it on a browser-based visualization that's actually pretty slick and smooth, even with, in this case, it's millions of samples. So here's just an example of zooming, panning, looking at the data. You know, you can drop some cursors. I'll just measure the frequency in a coarse way of this, as well as the amplitude. So drop down some cursors on some of your waveforms, and there you see, it's hard to see, but it's 10 microseconds. It's a 100 kilohertz square wave, so that all makes sense. So that's all inside of the browser and all inside of TekDrive. So let's go over to TekScope and see, you saw you could do coarse grain measurements, but in TekScope, you can do much deeper measurements on that same TSS file. So I'm going to go to File Utilities and mount a new TekDrive. This is where you'd also mount a network drive, but here you're mounting a TekDrive. You can tell it to disconnect. So in this case, you're on TekScope, but also this works on a normal scope. So in case your scope is shared, you can have this automatically disconnect on power cycle or after a few hours, so that someone coming up after you to this piece of software or scope doesn't see your data. So I'm going to go ahead and connect to TekScope here, and you're presented with a QR code. You can grab your phone and scan the QR code and then log into your TekDrive account from your phone. But I'm going to go ahead and use the browser because it's easy to show. So I'm going to go to drive.tekcloud.com/activate. I'm logged in with my account. So I'm actually pairing this scope. This action is pairing this scope with my account. So I'll type in the short code. You're probably used to something like this with Netflix, whatever, on smart TVs. This is saying that the oscilloscope is about to have access to your files in your account. Of course, you know that's going to happen because you just kicked it off. Activation successful. And now TekDrive is just another part of your file system. And again, this works on TekScope and TekDrive. TekScope and the actual 4, 5, 6 series scopes. So now with TekDrive and cloud-based systems, you have a way to make your files show up anywhere, whether it be in the lab, on your PC, or any connected device, including phones. So I'm going to grab that same file that I had before, which was FFT plus 3 channels, the one that we were looking at in the browser, load that up in TekScope, and of course now we can make much deeper measurements and do all the things that TekScope can do with this. Again, this is not a screenshot. This is the full glory of the data. So let's imagine what this workflow that couples TekScope, Scopes, and TekDrive all together might look like in an aggregate way. So let's just pretend that user 1, user 2, and user 3 are all in separate locations, and they all share a folder on TekDrive. User 1 saves a TSS file, let's say in San Jose. Instantly, user 2 can open that file inside of TekDrive in, let's say, Germany. So what just happened there is that user 1 saved the file and immediately user 2 had access across the world. Maybe user 2 is running a Mac and can't run full-blown TekScope on their PC, but they can still do some analysis or take a look at this shared piece of shared data, just because TekDrive has the capability to do visualizations. And then finally, let's say user 3, let's say in some other part of the world, now instantly has access to that same thing. Let's say they do have TekScope installed. So now this file that originated across the world is now opened up in TekScope with full new measurement capability inside of TekScope across the world. No USB sticks, no email, no screenshots. This is a full cloud connected workflow. So that's just a demo of how to get things into TekScope with files and using TekDrive. Let's talk about getting data into TekScope using the remote control. So I'm going to let one of our AEs show you how to do that with Multiscope here in a bit. But first, I want to just show how you connect to a scope. So here you'll see on the bottom, I'm just saying add new scope, and you can type in the IP address. So this is common. You can, if you're familiar with eScope, you can do this in a browser. But with the latest TekScope, we've added the ability to connect to a scope and show the live waveforms directly inside of TekScope. So again, I'm in a piece of software called TekScope, but I've now connected live to another scope that's on my LAN network. So now I'm looking at the equivalent of an eScope live panel running inside of TekScope. And that's great for one scope, but where it really gets interesting is when you connect to multiple scopes. So you see I have the 2 channels from the scope already in TekScope. Now I'm going to connect to another scope, and now I have 4 channels, 2 from each. And in this case, I've actually taken 2 different scopes and 2 channels on each, brought them into the same interface. I can also have real-time connection to those scopes individually right in the same interface. And you can see I'll put it on to run mode just to show like this is alive. So now you've really got all the levers you need to either remotely control the scope so that you can make settings on the scope directly. You can control the scope inside of TekScope, and we'll talk about that. And when you do that, you can aggregate multiple channels from multiple scopes all inside of TekScope. So this multi-scope capability, let's take a look at it. You'll probably have questions about how does it trigger and like how does it, what's the synchronization that you can do? So there's 3 different operation modes, we call it, for multi-scope. Number 1 is the no triggering situation. This is just, you can connect to a scope and then refresh the waveform. So whatever is on the scope at the time, it will bring it into TekScope. So you could do this with multiple scopes and bring data from 2 scopes into TekScope. The second type is it transfers upon triggering. So you set the triggers on the remote scopes, and then you say acquire. And when the scope hits the next trigger, each scope hits the next trigger, they'll send their data into TekScope so you can see the multiple channels in the same system. Here, you can set it up to share triggers, and we'll talk a little bit about that. Finally, you can couple remote control with multiscope. So here, the scopes still send the data on their trigger, but you can actually set the trigger, the horizontal, and the vertical centrally in TekScope and send those settings out to all the scopes you're connected to. So here, it feels much more like you have one scope with one acquisition, but it has 32 channels. So because you can set the trigger, horizontal, and vertical in TekScope, and then those settings are farmed out to all the connected scopes, it's almost like you really do have a 32 channel scope at that point. So those are all the different ways that you can trigger multi-scope. We'll look more into this, and we got a nice demonstration from one of our AEs, like I said. And then finally, let's talk about synchronization. So these are the different synchronization ways that you can get. It depends on your needs, and there is deskew capability. But between the idea of using an signal or source generator to create synchronization, or deskewing the jitter out of that to get even better synchronization, or using the aux in and aux out trigger sharing capability, you can do that. Also, people in some cases just, I guess you'd call it burn a channel, but have both scopes triggering off of the same node. So those are all ways to make high channel count systems with multiple scopes inside a TekScope. So let's take a look at this, where one of our AEs have put 3 scopes together and seen lots of channels.
Hi, my name is Junwei. I'm an applications engineer at Tektronix. This is a demonstration of the multi-scope capability of our TekScope analysis software. We have 3 8-channels oscilloscopes probing a variety of signals from these FPGA boards and connected on a network to my laptop that is acquiring the waveforms from all 3 scopes. This allows you to view and analyze data from multiple scopes on the same screen. In this case, we have 24 channels. The software allows you to connect up to a maximum of 4 scopes, giving up to 32 channels to acquire. Next, we'll take a look at the software. To add a scope, we simply navigate to the bottom and click on the Add New Scope button. Enter in the IP address of the first scope and click Connect. Once it completes, you can see it successfully brought in all waveforms from all 8 channels. Now let's do the same and add the second scope. We change the IP and click Connect. Now 16 channels are loaded, and we can add our last scope. When adding more than 2 scopes, consider using a higher resolution display, preferably 4K and above resolution. And here's all 24 channels. With a single set of controls, we can easily pan, zoom, rearrange, and add measurements. Here you can control which channels you want to be visible and active. To conclude this video, TekScope allows you to efficiently acquire waveforms remotely and lets you do offline analysis. You can synchronize multiple waveforms into a single virtual instrument on the PC.
Cool, so you can begin to see how TekScope brings together lots of different scopes into one system, and doing that, you're able to really offload a lot of analysis. So we talked through all the different capabilities of TekScope and the ability to share files through TekDrive. Let's talk a little bit about the buying of TekScope. So there's 3 levels of licensing: starter, professional, and ultimate. They have either a perpetual license with maintenance, or a 1-year license, which is cheaper. Here you can see the different capabilities that you'll get with the starter, professional, and ultimate. With the starter, you get the base package as well as some serial decode, and the starter package allows you to connect to 1 scope at a time. You also have that PI interface for automation. With professional, you get all of those things as well as one of the pro licenses, and we'll talk about the pro licenses on the next slide. And then finally, in ultimate, you get everything, and including all of the pro licenses as well as the full multi-scope system. So if you're planning on bringing multiple scopes together to create a 32-channel scope, you would need the ultimate. It also adds some spectrum view time versus time capability and user-defined features. The pro licenses are divided into 4 groupings across applications. There's serial decode, power, aero and defense, and automotive. And we've placed various ones of those into the proper category for each of those types of applications. Also, there's a line there at the bottom that shows all of the scope models that TekScope supports. So if you go to scope.tekcloud.com, you can learn more about this, and also drive.tekcloud.com to learn more about TekDrive. I hope everyone's enjoyed this walk through the ability to do remote analysis with TekScope and TekDrive, and I'll turn it back over to Rebecca.
Thank you, Rick, for taking the time to be with us today, and thank you to anyone who's joining us for this presentation. Just a reminder that you can share this presentation with colleagues, and you're able to go back at any time and watch the presentation at your own pace. If you're looking for more great technical resources like webinars, white papers, or app notes, please visit our TestForce Academy at testforce.com/academy. Thank you, everyone.